Welcome to our video presentation for Chapter 11 of CJC 390, where we will talk about arson tonight. A little quote from Sherlock Holmes to start us out here. That's what we're looking for. We're looking for the truth, and in fire investigations, we're looking to see if it was in fact an arson or some other type of cause. I have a good idea why that fire may have started. Alright. So for this one, we're going to define what arson is and issues that complicate these investigations, causes of arson, how we collect evidence in arsons, and we'll also talk about explosives too. We'll talk about two broad categories and two types of high explosives. Arson is basically the burning of another's property for one's own property for some sort of illegal purpose. So there's various reasons why arson might be committed. In some cases, a property owner does not want to keep up a property anymore. They just want to collect the insurance for the property, so they burn their house in order to defraud the insurance. It could be used to cover up crimes such as homicide. Juveniles may set fires out of curiosity. It could be related to revenge for some wrongdoing between two individuals. Extortion is similar to that. Terrorism, obviously, and it's somewhat rare to have pyromania as a cause, but occasionally you encounter that as well. Arson is a much bigger problem than most people realize. It actually costs billions of dollars annually. It increases insurance rates, and it obviously causes danger to neighbors. One of the most significant problems with arson investigations are the fact that fire departments simply try to do the work that they're supposed to do, but in the course of that process, they really can cause issues with our attempts to perform an investigation. So if you think about the fact that they douse a scene in water in their rescue attempts, and that they do rescue procedures such as cutting into the structure, and also merely the fact that fire is fire and it's very damaging, that causes problems with the evidence that we could potentially locate at the scene, particularly some of the types of evidence that we've already discussed, like impression evidence, like fingerprints and trace and that sort of thing. So when we have an arson investigation, or when we do a fire investigation period, we're trying to determine two things primarily: cause and origin. And first we'll look at origin. Where did the fire start in the house? And that can give us a good starting point to figure out what started the fire, period. So if it's an electrical fire, we would expect to find damage near an electrical outlet or something along those lines. But if we see a potential use of an accelerant, that's an indicator of arson. Or how did the fire move? And oftentimes we'll interview firefighters to get that information. And also, where was the fire most extreme? If we find that in an odd place, that might also be an indicator of an arson. Origin is determined by looking at different things. Depth of char simply is the depth to which the burn manifests in a piece of material. The degree of destruction obviously is bigger where the fire was more intense. Spalling is the actual flaking of concrete that occurs when it gets to a certain temperature. It has to be fairly high temperature. Metal or glass tends to bend or melt in fires. After all, that's how they make glass, is through a burning process. And sometimes if we also locate multiple sources, well, that's a big clue to us too that we have a potential arson. Regular electrical fires or fires by accident through cigarettes, those usually will just have one source, obviously. So after we determine the origin, or in conjunction with that, we're also looking at the cause. So what is the cause? Was it a faulty electrical appliance or merely old wiring in a house? Accidental, as I mentioned, could have been a cooking accident. It can be something like careless handling of smoking materials. Lots of different ways a fire can happen accidentally. I would even say a clandestine drug lab, which you're going to look at in this course, could be determined to be an accidental fire. They meant to cook their drugs and not cause a fire. We also have arson, obviously, which is the intentional setting of fire. So in order to set an arson, the arsonist usually wants to cause maximum damage. So they will use what's called an accelerant, igniters that they pour into a house in order to make the fire burn stronger. As we all know, things like gasoline and turpentine, they tend to burn quite easily. And we'll see indications of that because those char areas will be quite deeper in locations where the fluid has been poured. And keeping in mind too that in wood floors and things of that nature, we'll often find where fluids run to the lowest point in the house. Gravity takes fluids, as we know, to the lowest point, so we'll find those fluids in cracks. Looks like a pretty severe fire for a garden hose approach. Alright, so if we find the presence of ignitable fluids, or what we call accelerants, we'll concentrate upon that area of origin to take our samples. And what we're looking for is to recover those samples and have the crime lab do a chemical analysis to see through usually what they call mass spectrography, to see what kind of chemicals are present in those samples near the point of origin. We'll also collect things like charred rags and rugs and empty containers, and if we see the presence of any fluids, obviously we'll take those too. We use what looks like a paint can for this type of evidence collection, basically just a metal can. And the reason why we use these is because the same reason why they put paint in them. They seal up very well. One of the problems with accelerants, if you've ever poured some sort of paint thinner or something on a surface, you'll notice that it evaporates very quickly, much more quickly than water. That's why they often put such tremendous fumes. You can smell the fumes at the gas station, and that's because gas evaporates rather quickly and puts off a distinctive odor. Well, you don't want your accelerants evaporating quickly at an arson investigation, so the paint cans keep them tight and secure. We avoid things like paper bags or even plastic because they can tend to allow that evaporation to happen. We don't need that much really as far as ignitable liquids. We don't need too much because the chemical processes that we can do in the lab can really get down to the very minute details and determine whether an accelerant is present. So we mentioned some of the common ones that we find: gasoline, also kerosene, charcoal, lighter fluid, paint thinner, and turpentine. At arson scenes, we also may collect building materials for comparison to see if there's perhaps some accelerant on these materials, and they can also determine or help us determine the degree of temperature in the fire and things of that nature. So your common building materials that you would use to build a house are listed here. Pardon me, if it's a successful arson, collect those obviously. And there's some other igniters that are used too. So the arsonist may have the goal of not being present when the arson occurred. So they may use some techniques that are a little more crafty, I would say, like candles or black powder, smokeless powder. Sodium and water is a mix that can cause a reaction, igniting a fire, or obviously electrical devices. So some arsonists who are what we would call serial arsonists, who commit crimes more than once, it's just like any other type of crime. We'll talk about burglaries as well, and they tend to repeat what works well for them. So the modus operandi of an arsonist kind of may denote several arsons that occurred. In outdoor scenes where an arson may have occurred, we concentrate on soil collection because the soil, just like the wood in a house, could potentially reveal some presence of accelerants. We also focus upon normal evidence if we can find that, so perhaps we'll find a shoe print leaving the scene, blood where somebody cut themselves, or any sort of DNA evidence can be helpful, obviously. If we find a suspect who has left the scene, so perhaps there's a suspect vehicle description given out and an enterprising patrol officer finds that individual and stops them, we're obviously going to want to look for many of the same things that we are looking for at the scene that are listed here, but also check their clothing and their shoes. So if they are pouring gasoline or turpentine around a residence, there's a pretty high likelihood they're going to get splashback on their clothing or shoes. And I would, in fact, if it were me, I would take them to jail if you had enough probable cause, and I would seize their clothing and shoes and send them to the crime lab to see if they can do that chemical analysis. If we find a dead body in an arson, obviously that could be an attempt to cover up a crime, or it could be somebody who died from natural causes, or it could be somebody who died in the process of an arson. So they died due to the fire. And what happens in answering the question of was the fire used to conceal a killing, the autopsy can actually determine that if there's enough body tissue left. They can determine whether or not the victim inhaled smoke by doing an examination of the lungs. People tend to die in fires from smoke inhalation more than anything else. One thing I'll repeat probably in the chapter 16 or the final weeks of the course about a death investigation is people need two different things to live. They need blood flowing through their body, and they need oxygen. The problem with fire is it replaces your oxygen with carbon monoxide, and you cannot breathe that. If they died prior to the fire, you're simply not going to find evidence of smoke inhalation in their lungs. Not sure they're going to save this home here. All right, so let's quickly, and we'll brush through this fairly quickly, and look at explosives. Basically, an explosive is any material capable of rapid conversion. And what happens in that rapid conversion process is it needs room to breathe, so so to speak, I would say. And if it doesn't get that room to breathe, it causes a violent reaction. So rapid conversion from either a solid or a liquid or a gas with heat, pressure, and loud noise. So the conversion process is violent. You have different types of explosives, such as low explosives, which tend to burn rather than explode, but rapid expansion of the gases from that burn can cause an explosion. And what you need for a low explosive to work is it needs to be tightly compacted. It needs some room to operate, so if it's compacted really well, it's going to cause an explosion. High explosives are two elements to high explosive. First, there's primary and secondary explosives. It's detonated by shock, higher velocities, and there's no need for confinement with a high explosive, so you could simply have the material have a primary detonator and it's a secondary explosive. You don't need it confined like in a pipe bomb or something like that. It simply explodes. Example of a low explosive is good old black powder. You all are probably more familiar with this than you think because they're used in fireworks to a great extent. Some other examples of powders, potassium, sodium nitrate, sulfur, and charcoal are used in these powders. Obviously, heat causes problems with them, and we see these in pipe bombs, and friction and sparks can cause them to happen too. So occasionally you'll get some enterprising explosive maker who doesn't know much about what they're doing, who causes a spark when they screw on the lids to these pipe bombs, and it causes immediate detonation and sometimes death, and at least a pretty heavily maiming injury to that individual. Occasionally you'll see the low explosive as smokeless powder, not too much, but occasionally you'll see them used in pipe bombs. Not as sensitive, so this may appeal to the amateur explosive maker as less dangerous, but it is still dangerous, and you'll find smokeless powder used in small arms ammunition when someone is attempting to make a cartridge that is good to use at the range. Smokeless powders are a little more desired because it helps you stay on target. The dog is on vacation. That dog has a nice job there. High explosives, again, primary and secondary explosives make up high explosives. So subjected to heat or shock that detonates the main charges, blasting caps, and firearm primers. We'll get to firearms later in the course. So essentially the blasting or the firearm primer is what causes the explosion in a bullet and propels it downrange. So remember that when we get to that. Different types of blasting caps are electric and non-electric. Secondary explosives simply detonate from that shock from the primary explosive. So they're almost perfectly safe without that primary explosive. So if you don't have a blasting cap or something like that to detonate the secondary explosive, not much is going to happen. Some secondary explosives that you might be familiar with or may have heard of is nitroglycerin, dynamite, which some dynamite, I would say, is made up of nitroglycerin itself. So these two are very similar. Ammonium nitrate is a fertilizer, and this is actually what Timothy McVeigh used in the Oklahoma City bombing of the Murrah building. If you're not familiar, that happened in the 1990s. You may take a look back at that. A large U-Haul truck full of ammonium nitrate, which is simply a fertilizer that farmers use. This is very suspicious, and I would say that could be an arson. Some blasting agents. Not too much time we'll spend on this one because we won't ask too much on the test on this. I'm not trying to make you explosive experts, but some blasting agents that are used are nitrocarbon nitrate and also binary explosives. You take two inert chemicals, and by inert we mean they're not very dangerous, but you combine them together and they can become explosives. So you'll see terrorists occasionally attempt to use this type of method where you take two different substances, and when you mix them together it causes a reaction and an explosion. So they can carry these around without danger, and when they're ready to use them they put them together and it causes a problem. Military explosives you'll find from time to time too. Flexible rubber-like quarter sheets are what they call TNT or RDX or military dynamite. You'll hear people variously call these plastic explosives. They require a detonation as well. You'll find individuals again make their own explosives, and they're not always to make something blow up or to cause harm to somebody. Some person may attempt to be making their own homemade firecrackers and have problems when they accidentally detonate those. But you'll see various things used: match heads, ammonium nitrate, firecrackers, and small arms ammunition to make these homemade explosives. When an explosive scene is examined, there's lots of questions to answer. What was the material used? What was the level of the skill? Anymore, if we get an explosion, typically we'll call out the Bureau of Alcohol, Tobacco, and Firearms, and they actually aid in the investigation of explosives. So sometimes they're called the ATFE because they also investigate explosive scenes. Who was the target? If there was a clear target, somebody has a vendetta against them, that may be an indicator. Was it an accident? Was there criminal intent? Where did the bomb and the materials come from? Where was it placed? Who was it for? What's the intended victim? And of course we're trying to find the suspect and how they detonated. What you see here is a typical EOD bomb suit. You may have seen a popular movie about this called The Hurt Locker, and it showed some similarities, some inaccuracies in there. Typically we don't approach explosives if we don't have to. What you'll see trailing behind the bomb suit donned person is a robot, and we tend to use robots a lot more in EOD or explosive ordnance disposal calls than we do humans. We can replace robots. So the process number one priority is obviously to make the scene safe in an EOD situation. We rely on experts to do this for us. We do not rely on your standard everyday first responder. So there are EOD teams typically scattered throughout states and metropolitan areas, including in my department. Concerns that they may have, they have to make the bomb safe, obviously, but are there secondary devices, such there was in the Atlantic Olympic bombing that occurred many years ago, where the secondary device typically is planted for one reason, and that is to hurt the first responder. Are there other hazards such as down power lines and things of that nature in the area that we must be concerned with. How we make the bomb safe, there's usually no wire pulling or anything in that nature. Typically, they take the device to a safe location and they blast it with a water gun or something in order to make it safe. So on the previous side, you can see an aerial photo of an explosion scene that reveals the extent of the damage. In explosion scenes, you want to search high too, because the debris can fly in weird ways, and you can find parts, body parts in some cases, or vehicle parts if it's a car bomb or things of that nature, on tops of buildings, for example. So a careful search is necessary, not only at ground level, but in high areas. Obviously, if the suspect's in custody, it may be possible to swab their hands for the presence of explosive materials. You also see that done at airports these days by the TSA. They do quick swabs that determine if there's any indicator of explosive materials on an individual. So their clothing can also be collected for this same purpose.